Okay, we're going to get going. Things are moving along really rapidly on the general atomics front. They're going to come here on Tuesday. And you guys are going to be treated to probably one of the most fascinating presentations that I've had the honor to set up since I've been here. The speaker is, I think he sort of is a hiring manager for them. He comes with a Navy background, and he's been doing a lot of research into why you might want to consider going into the workforce with a 2-year vocational training certificate, and then using that to kind of pivot to a 4-year engineering degree some years down the line. Because you get anyway, he's got a lot of great stuff to kind of share with that. I'm pretty amazed at all the homework he's doing to validate our efforts to get a 2-year mechatronics training program going here at NPC, with like training in robotics, automation, maintenance of technology, the kind of activities that's fairly easy to get entry-level positions in. And that initial experience can kind of set you up for some additional education you might want to get later in engineering or other fields. But I'm not going to spoil too much of what he's going to say because it's going to be pretty awesome. And I'm about to make an announcement to as many of the STEM faculty who will share that to their students. And so I kind of thought we might need a bigger classroom, a bigger meeting room. And I'd like to invite you all to bring anybody along who you think might be interested in this position. As I mentioned, if you weren't here, I think everybody's here, but the General Atomics is the company that kind of builds and maintains the Predator drone program for the military, and they're out of Palmdale, and they have a dire need for skilled techs to kind of help them with keeping that program going. And anyway, it certainly sounds like something that will be a really interesting talk, and probably a lot of really exciting stuff. And our own former alum, Rachel Gaines, is going to be here as well. She was here about 2 or 3 years ago. Finished up her electrical engineering degree education and is working for them now in a similar position. So, the plan for today, and I was just on the phone with him, so that's so we're gearing up for that for Tuesday. And do you all know, you all know where the Sam Karras room is in the library? This is the you probably don't. It's the when you're going down the that brick walkway to the main doors of the library. There's a couple doorways on the right. Joseph, you're shaking your head. Have you ever been to the library? You know those bricks, that brick walkway to the library, when you go down the main pathway to the library, there's some doors on the right. Well, you're going to be there on Tuesday, right? Good, you should. It's going to be really cool. Yeah, it's a Sam Karras room. I'll have some signs up there so you won't get too lost. I'll probably be standing around outside. It's a nice entryway. You can just enter the room right from that walkway. You don't have to go through the main library doors. Don't go into the main library doors. Just look for the classroom. It's a meeting room doors on the right as you go towards the library. So that's where we'll be, and I will send an announcement out about that in case anybody's not here today. And like I said, feel free to bring anybody else you'd like. There'll be plenty of seating there. And then today we're going to have a visit from Veronica, who is an engineer at a company in Morgan Hill. I forget the name of the company. Actually, it's a pretty famous name, I think, but I can't remember it right now. And she's going to talk a little bit about her work. She's also our instructor for the engineering graphics class. And so she's actually giving an exam today, of which Jeremy is taking it. And so she will show up at 5:15 to collect your exam, and then talk a little bit about her her work background and as a mechanical engineer. So until now, we had about an hour to kind of do some other stuff, and this is the perfect time to get into a design modality. As we kind of mentioned before, design is kind of it's a big part of engineering, designing stuff, designing products, designing processes to meet criteria. And the class that Veronica teaches is called Engineering Design Graphics, and at the end of the class, there's a sort of a design project where people can design something and make it in like a 3D printer or whatever. So design is really cool, and yet design is not easy because design is not a problem where there's only one right answer. There's many right answers to solving a design, and we're going to start a design competition. I was going to do it next week, but given our visit, and then I may myself have to be out of town, perhaps on Thursday, I think we might postpone that a week. But you're going to have a design challenge where you get to design and build a bamboo tower, which is going to hold a certain amount of weight. And again, there's a lot of ways of solving that problem. We'll have a competition to see who can come up with the best way according to the requirements that can do that. So for now, this is a kind of an impromptu thing. I'd like you to take out a piece of paper, or if not, I'll just pass out the paper. And I want everyone to, and you can think about this right now, we're going to do an activity. Designing a product. And it's going to be a certain product. The product is going to be a solar oven. Does anybody not know what a solar oven is? What is a solar oven? Who knows what a solar oven is? You cook with one. What do you think? Tin foil and cardboard, you put food in it somehow. Could be. Yeah, the solar oven. So it's powered by the sun. And what does it do? It cooks food. Why would it be useful? If you want white paper, unlined paper. A solar oven is designed to heat a meal, maybe cook a meal, using only solar power. Right? You can magnify, you can concentrate, you can whatever. And in fact, well, I don't know. I mean, I could probably bring up some design, but I don't want you to search for a solar oven and look up what other people have done and all that stuff. I want you to think about, just off the top of your head, how would you design a solar oven? It's a product that's a little, it's still like a tower. Everyone's going to kind of do something fairly similar, but a solar oven has a lot of ways of solving it. And I'd like you first to try, just come up with your own idea for how you might do a solar oven. Sketch out a picture of what it might look like. You could add words to describe how you would actually build it or how it would actually be constructed. And I just spent about like 10 minutes doing that. And then what we're going to do is I'm going to give you some cards. We're going to talk a little bit of a design activity. And we'll see if these cards will actually provoke a different approach to it. But the first thing, I just want you all to give you a shot with your own understanding of what a solar oven is and what that might look like. You would be a task design build. Any questions on that? 10 minutes. You can talk with your neighbors about it, discussion with partners. But I'd like you each to kind of think about your own version of what that might look like. Questions?
Like off scratch?
Yeah, so don't search for solar oven, please. Yeah, try not to do that. I'd like to just do it. Use your own mind. What would a solar oven be? How would you build it? How would you design it? Please resist it. First thing on.
Scratch.
Definitely has to be
Somewhere. Because we use make it work. Makes it work. I remember I did one when I was young. I did something like this when I was like a kind of and these are like solar panels. Cause I did one with aluminum. If you wanna like concentrate, I guess you can use mirrors. Somehow connecting to a mirror that would reflect the lights around it. It's more like concentrating heat into one spot. Are they agarrar the heat from like an open space and let it like attack into it. That would, but it's just a better design.
I was just thinking of one that basically opens up like this, and always on top is like a solar panel sheet, you know? And it's mostly like rectangle inside. So it's going to be thick here, so it can be deep inside. You know?
No, yeah, I mean, because it's a como, you can put aluminum in it. Aluminum inside the wall, so it's
Insulation.
yeah, we usually we like that. Too much sun hits, kind of make you reflect into it. It's the middle one that just drops. What? I remember I did it when I was little. It was just like sixth grade.
It requires a now.
Another 4 minutes or so, try to kind of finalize your design. You know, clarify it as much as you can so that you could actually build it. You know, what kind of materials would you use? You know, how big would it be? If you have some lenses involved, how would you support the lenses? You know, I saw some lenses hanging out in space. How would those lenses actually stay there? What would you use to keep those lenses where they belong? So you should have a design that you could probably build a prototype of. You know, you could go home and just start putting these together.
We were thinking that we had like a recycle.
Well, I mean, sure. I think like what might they do it?
No, we were just saying like simple, like the simplest answer. But then he scared that like it was a smart idea.
And then this is so.
Other than training? Yeah. Good, it's a renewable thing, sure.
Why just these out?
Okay, and then put your name on it. This is your work. And don't let on the other side. Hopefully you didn't use two sides. We'll use the back side for your second. You need more paper? Sure.
I wrote on the side. So can we like totally replicate this?
You can use anything. Yeah, it's really open-ended. That's the thing about design. Right? Yeah, then put your name on it. Everyone put your name on it. You're the engineer behind this. This is your work. You'll be turning this in when you're done. Is everyone still working right now? I'm good. Those two good? Oh, you're trying to do, no, you're not doing your second slide yet. No, you're not doing two yet. You're just doing one, and then I'm going to give you a strategy for your second slide. Okay, Jahi, it's about finished. Maybe one more minute. Okay. How do you like this? No, you just hold on to it for now. On the back side, you're going to do another activity, but don't do it yet. So just feedback. How was that for everybody? How did you like that? Enjoy it. You can see why engineering graphics class would be really useful. Yeah. And that's with Veronica, so it's like the timing is just perfect, you know, for Veronica. I didn't plan this out with people. For career, she can talk a little bit about the engineering graphics class as well. Is anybody in that right now? I know, well, I guess you're in. Are you in too? Are you took the class, you took the test, are you taking the test tonight? Saturday. You're taking it out. Good. Well, Jeremy can feed you some information, but he's not allowed. No, he's not. So the design, so this is design, right? And this is actually like the complete opposite of what you have to do for your engineering education. All you know, the whole time you're getting your education, you gotta learn calculus, you gotta learn how to differentiate and integrate. And all these things, you gotta solve physics problems, you gotta solve engineering problems, analytical problems, you gotta find the force and a B, you gotta do this and that. And they all have one right answer. This is like open-ended stuff. And this is where like new product formation comes in. This is like the engine of our economy. When something comes up, new design, new stuff, you know, new ways of doing stuff that we're familiar with from old. You know, people are still like redesigning their toothbrush and trying that out, right? You see it changing every year. Cars every year. There's a new design for the same car. You know, they just keep updating the design, or they keep improving it. Things getting better all the time. Looking at the boys, I'm just kind of marveling lately at, you know, how microwave ovens used to kind of have to like punch in exactly how much time you want. Then they have these like, you know, add 30-second parts. You know, you just stick something in and just press that. But somebody thought of a different way of doing the same thing they've been doing over and over again. And it takes a while, you know, for you to realize the problems in our current technology to kind of think about ways of improving it next time. And one way of addressing the final project I've done when I taught the graphics class is coming up with a bug fix. You know, something that annoys you about a current product, and then designing a way to improve it. So design is just a really, really important part of a lot of what's going on in engineering. But you know, not every engineer is going to be a designer. It's just something that some engineers do. Some engineers are really good at it, and then there are people that are not engineers that just design products and they don't actually know how to build them. But engineers actually have the ability to not just design stuff, but actually, you know, figure out how to make it as well, which puts us in a really cool place. So I'm going to share with you some materials that I got from a workshop at a conference in for engineering educators, and this was a group that was funded by the National Science Foundation to improve people's designing abilities, because you know, it's kind of observed that when you first start designing stuff, you tend to grab the familiar things that, you know, you tend to reach for things that are kind of been done already, right? Stuff, you might have seen a solar oven, you might have seen some, you know, something like that somewhere else. You kind of know how to magnify stuff. So you do that, right? But those are actually not often the best products when people design that way. You're doing stuff that someone else might have figured out already. but really, you know, why did the iPhone, you know, take off? Well, it was sort of the first really well-designed smartphone. It wasn't like anything anybody else had actually done. So we want to actually have a way of breaking through to approaches and perspectives that will yield better results. So, so the typical design approach is to start with a problem and then research and gather information about a design, you know, problem that you're trying to solve, and come up with a few different options. So you kind of brainstorm, right? And then you know, you pick one of those, you generate some concepts, and those might lead to other products, and then you kind of finalize with a particular one. And where we're going right now, you can kind of see that you know, all three of you might have a different approach. If you guys talk to your neighbors about that, you all have different approaches. You all have similar ideas. What about any group that had really different approaches? What were your different approaches in a nutshell?
I heated water using a parabolic surface with water going through a pipe at the focal point, which then heated the food.
Okay. Okay.
We hooked up the solar panel to an electric oven.
Solar panel to an electric oven. Okay. You said metal panels to reflect the light in a certain way. Okay. Does anyone else have any novel ideas? I saw some with magnifiers, you know, to concentrate it. Right? That's pretty cool. Anyone else have any ideas? Well, the point is, you know, we each kind of come up with different approaches, and then you might decide to combine a couple of them. You know, maybe you have some solar panel with some additional concentration or something. You can come up with a product that way, where you're kind of finally you kind of narrow it down to one design, and this is the design that you invest all your energy into to create, to refine, to market, and sell. So, but that's actually kind of what they teach you in a lot of engineering classes about design. And yet, it doesn't lead to necessarily really good design outcomes. There tends to be a problem, especially when we're just, you know, we're students and kind of learning about. I've noticed this a lot. People will like fixate on one thing. They get an idea, they think it's kind of cool, and then, especially if they're working in a team, they really work to kind of get that idea promoted and do that. I had this one group. They were doing like a design effort for like a business class, and they came up with the idea of a smart pencil that would just record all of the writing that was being done inside the pencil, so you could kind of download it. And you know, it was a really cool idea, and they wanted, but they you know, they really wanted to take it and actually make it. They were asking me to like help them build it, and I'm like, dude, I should help you do that. But what was interesting is that they were really fixing that. They just thought this was like the most incredible thing, and it would make them $1 million. And it might, you know, but ideas are actually, they're kind of easy to come by. Actually making something that works is kind of the hard part, right? So people kind of often fixate on something, and they kind of fixate on things that they've seen before and their experience, the first idea that comes to them. And it's difficult when you're starting out in design to kind of generate multiple ideas. And so often the products that people develop are kind of stuck in a sort of a routine design kind of pattern, right? So this group was funded to try to help come up with different ways. So it actually looks maybe something like that. You know, it's a very narrow design space, so the solution doesn't necessarily bring in a lot of novel approaches. But the challenge is, how do you actually promote more creativity and diversity that could lead to innovation? Things that are like really different, really crazy approaches that would not really be necessarily thought of by somebody who thinks of solar oven. Solar oven kind of has an implication. It doesn't really sound very sexy, you know, but you could maybe take it in a weird way that could make it really cool. And this idea of coming up with really different ideas that are diverse, that could lead to a really innovative product that could be very successful in the market. And so what they came up with was a technique. And we're going to use some concept generation techniques to generate different ideas. And then you don't evaluate those until, or is this something else that's failed? I don't know. Here we go. Yeah. So we're looking at these cognitive heuristics that are going to really kind of help you take it into a different dimension. They're not going to necessarily guarantee the best solution, but they may lead to potential solutions that you would not have normally thought of. These are cognitive heuristics that help people actually come up with new ideas. Design heuristics are going to be are like concept modifiers that lead to a potential solution, and then they help you design something novel. And so what we have, what they gave us, and I got a set of these things, there are these 77 cards for helping kind of shift your perspective on a particular design problem. And the concepts are actually kind of abstract. What they actually did, the people actually that did this project, they actually met with successful designers. They actually sought out actual working product designers, and they actually tried to figure out, how do you actually design a new product? What kind of processes do you go through? And they shared some of the techniques that they do, and they encapsulated those into these 77 different cards. Now, you might find this a little bit challenging as well, but the idea is, suppose you're sitting here thinking about solar oven. You have a few ideas. These are kind of obvious. And these cards are going to try to take you out into, like, the fringes of possible solutions. And those should actually give you ideas that take you outside of sort of the mental blocks we sort of all get in. It's really common for us to do that. So as an example, these are the kinds of activities you're going to get. Now, it's going to take you in a different direction, but you actually have to be willing to go with it, right? So the idea is, if you got this card 13, you would be asked to apply an existing mechanism in a new way in regards to your solar oven. So you would take something like a chair, and maybe here's an example of like a chair turns into like something that you can maybe flatten something out. Maybe this could be a chair that turns into like a dough roller for a pizza. But how would this actually relate to a solar oven? An existing product, an existing mechanism, using it in a new way. Yeah. Yeah, that would be an example. Yeah. Oh. What an existing mechanism. How could you use like a bicycle wheel? Yeah, like a space blanket. A space blanket. Yeah. Uh-huh. Yeah, that's good. Space blankets are really existing items using it in a different way. This could be something, a camper could use to stay warm at night, or they could use to cook their food. Yeah, right. So that's so it brought you to a new approach, right, that you might not have thought of before. And you're going to each get for the next part of this activity, you're each going to get a card. And the card is going to have, on the front side, it kind of has the idea, the concept, and then it shows you some example applications. Again, this is the same card number 13. And then these are some products that people have actually they've used that concept. It illustrates the use of that concept in a new product. So here's an example of a desk organizer that uses brush bristles to hold things like pens and business cards. Right? Kind of clever. It's an existing mechanism. You're using a brush in a way that nobody's ever really thought of to hold cards and pens. What about this thing? Hand vacuum cups that you use to transport large sheets of glass. Have you ever seen those? The glass makers or glass that people use. You ever saw those? Or the people that climb up buildings with these suction cups, Yeah, James Bond or Tom Cruise, Mission Impossible. They're using those suction cups. Right? They're pretty handy in glass. They make a good suction. You can hold glass really well. Well, here they're used to hold a seat and the back of the chair in place. So obviously, you got to be thinking about, what kind of products have you seen that are kind of cool out there, and how can you use them in a novel way? you actually have to go back into your memory to see, you know, what inspired you in the past. And wow, that was a pretty cool thing. I wonder if I could use that for a solar oven sometime, right? And that would be the effort that you'd be using, that you'd be doing to kind of apply these things. So here's another one, utilizing the opposite surface. This is kind of fun. Create a distinction between exterior and interior, front and back. Make use of both surfaces for complementary or different functions. Increase efficiency in the use of surfaces and materials or facilitate a new way to achieve a function. So here's something, again, basic shapes. Maybe we normally think about, you know, putting shapes on top of a flat surface, but what if we stuck a shape below a flat surface using the other side? How would that work, say, for existing products? Well, here is a weird shoe where the laces wrap around the bottom of the shoe and connect with the sole. That's kind of using the bottom of the shoe in a way that nobody's ever done before. Or this chair, the back of the chair, actually has a little pocket where you can store stuff. We never really think about using that part of a chair for anything, right? But why not, right? And again, these are design explorations. These are not necessarily going to be final products, but converting for a second function. Well, maybe you have a product that has multiple stable states, and maybe when it's in this place, this way it's a chair, maybe here it's a bed or something. I don't know. And different ways of attaching or orienting stuff. And other products that have used that, here is a table that features the folding top that can flip up or down, making it useful as a room divider, right? The table, a room divider, right? So it has another function. Or gravity balance, a recliner that has multiple stable stages. Notice there's actually sort of these flat spots. So you can lay back on it. You can kind of put it this way so you're more upright, and it's stable in multiple positions. That's kind of really clever, right? These are really novel type approaches to, you know, problems that we've sort of thought of as being relatively, you know, boring, but you can actually do something really cool with it. So, any questions about that? So we're just going to do this activity, and I'm going to give you each one. And remember, there's a front and a back side to each card, so make sure you read both sides. And I want you to tackle the solar oven again, using the content, using the idea expressed on your card. That's going to be, so on the back of the sheet, turn it over, you're going to put like the card that you used on it, and the card number, and then another attempt at your solar oven. Okay? And I will manually or already sort of shuffle. And it's really a chance to kind of have fun, creative, about this.
No, this is kind of break it down.
And if you really don't like your card, let me know and I'll give you another one. Okay. You only get one chance. You don't know what your other one's going to be, so you're taking a risk. If you really don't like your card, let me know. I'll give you another. But you're stuck with the other one. If you want to look at the other one first, it's fine. Yeah, if we don't like yours, let me know and I'll give you another one.
Yeah, I don't really know. You can't really do that. You get a push it, it's like add power to it.
So we don't have.
Yeah. Guys, your second time.
Voting goes before
Oh, yeah.
Maybe try that. Just add like a magnifying glass to it. So you can take the sound.
Instead of having try it.
It's great.
Have a little rubber up and down.
Wait, so
Yeah.
I can use my